learn how to calculate distance using the distance formula. We start with a massive catastrophe. On the 10th of March 2025, there was a massive North Sea ship collision. This happened off Withernsea, England, in the North Sea. The coordinates of the collision seen at the bottom. We will now take a quick look at a brief video clip showing what happened in this massive ship collision. So what we can see from that video clip is that the calculation of distance using coordinates would be massively important for the captains of both ships. If these captains had accurate radar systems that could discern coordinates and distances between the ships, this catastrophe may have been avoided. I've created a simple Cartesian plane with an X and Y axis to assess the situation of the ships before the collision. We will therefore learn how to determine distance using values on a Cartesian plane. We have our ships at these two X locations. Of course, on our Cartesian plane, we are using simple values. We are not using lines of latitude and longitude as radar systems would use in a real-life situation. To work out the distance from the one ship to the other, we'll use our distance formula. The distance formula is derived by using the Pythagorean theorem. In moving from the one ship to the other ship, we have a vertical component and we have a horizontal component. Those two components work together to help us determine the purple distance. Using the Pythagorean theorem, we know that the square of the blue side is represented by, and we know that the square of the red side is represented by, and the square root of the sum will give us our purple length D. To actually work out this distance, we will follow these two steps at the bottom of our page. Step 1, write the coordinates of the points. Our first point, we look at our X value, 7, and on our Y axis, the value is, for our second point, our X value is 9, and our Y value is 1. Now, to keep it simple, I just label my first point to the left as my x1, y1, and I label my second point to the right as my x2, y2. Now, step 2, I substitute the x and y values into the formula. So, here we go. Our x2 was 9, our x1 was 7, our y2 was 1, and our y1 was 3. We plug these values into our calculator, and our calculator will give us the square root of 8. And if we convert the root of 8 to a decimal, we get 2.83 miles. And that is how we use our distance formula. Progress check. Try use our distance formula for questions A and B, then check your answers with mine. Withernsea and Humberston. We substitute into our formula. So our first point is to the left, that's x1, y1. And our second point is to the right, x2, y2. Let's substitute in. x2 was 2, x1 was 1, and we square that. y2 was 2, y1 was negative 2. So I'm subtracting a negative 2, and I have to square that. So we have the square root of 1 plus 16, which is root 17, and we plug that in our calculator and we get 4.12 miles. Our second question, Humberston and Hull. Let's get the coordinates for Hull and we substitute into our formula. x2 was negative 3, we subtract x1 which was 1 and we square it. y2 was 3, we subtract y1 which was negative 2, and we close that in the brackets, and we have to square that. So we have the square root of 16 plus 25. That will give us the root of 41, and the root of 41 is 6.4 miles. And that's a wrap, guys. That is exactly how we use our distance formula. We simply write the coordinates of the points, substitute the x and y values into the formula, and boom, we'll get our distance. Hey guys, this is Casey at Onetree. If you like the content, please remember to like and subscribe. Also, if you'd like some online tutoring, please email me at onetreemath@gmail.com. Cheers.